Okay, so question 2.2. Some students wanted to compare how much each type of bag stretched when a force was added. So we're looking at a bit of a data handling question here. So they used the following method. They cut 10 centimetre strips from a bag. They clamped the strip. That's the strip. They're using masses to hang off the bottom, and they're measuring the new length each time. And if you can see in the table, you've got the amount of force added, okay, in newtons, and then you've got the different polymers that they did that for, and for each force, what the new length was. Okay. And the question says, the first question says, draw the line of best fit for polypropylene. Well, when they say line of best fit, if the dots are going up in a curve, then technically you're asking for a curve of best fit. Okay, but we don't call it a curve, we call it a line. So your line of best fit goes through as many dots as possible, but it's got to stay smooth. So you may get the odd one above or below the line, and that's okay. Give one variable that they needed to control. Well, you need to know that control means keep the same to make it valid. Well, your clues are pretty much here, okay? So look at what was it. So if you go back again, the way I break it down is, what were we changing? What were we measuring? So the dependent variable. And what were the controls? So we were changing the bags, weren't we? And we were measuring the length. So what would we need to keep the same? Well, you'd probably want the same length strip of bag, so the 10 centimetre lengths. You probably want the same thickness. So things to keep the same would be the thickness of the bag, so that, because if they're thicker, you get more stretch out of it. Possibly the length. You could even talk about the width, because the wider they are, they're probably able to stretch more. Suggest how the students calculated the extension. Well, if you go back to the table, they were measuring the length each time, so how do you work out how much it's changed by? You take them away, don't you? So they subtracted the length from the initial length, okay, out of 10 centimetres. So to work out the extension, this is a table for extensions, so it tells you they work these out from taking away the new length from the old length. Okay, suggest why students could not complete table 1 for polyethylene and polypropylene. And the only reason that you could probably think of they can't complete it is because something must have happened where the strip snapped. A lot of you got this right. You said it either snapped or it ripped or it broke, so well done on that one. Identify which polymer stretches the most easily. You have to use the graph to help you. So if you can see, polyethylene stretched with a much less force. So it would be polyethylene, and your reason why could be that it rose, the line rose up more quickly. You could say it was a steeper gradient. Depends on how you want to word it, but you can see from the graph that it goes up the quickest, yeah? Or it goes up with the least amount of mass.